Okay, let's take another set of examples where we have to find the derivative using the power rule. So in the first example, they say to us we need to find dy over dx if xy is equal to x cubed plus 2y minus 8, right? Now on this example, you will notice that they want us to find dy over dx, and if you look here, you've got y here, you also have another y there. So the simplification requires you firstly to make y the subject of the formula before you can even attempt to find dy over dx. So I'm simply going to take this 2y to go and join xy on the left by subtracting both sides 2y. So I'll be left with xy minus 2y equals that x cubed there minus 8. Now, after, you will notice that xy is a common factor here, so we can factor it out. You're going to have y into x minus 2 equals to x cubed minus 8. Right, now I can divide both sides by x minus 2. So if I divide by x minus 2 this side and that side, I'll be left with y equals to x cubed minus 8 divided by x minus 2. Now this question is a very nice question because you can't find dy over dx if you have a situation like this. So the numerator is a difference of 2 cubes, so we can factorize that before we even attempt to find dy over dx. So this shows you that sometimes it's not the problem of calculus, but your algebraic skills that prevent you from finding the derivatives. So let's factorize the numerator, which is x cubed minus 8. That's actually going to be x minus 2, right, into x squared plus 2x plus 4. That's the factorization of x cubed minus 8. That needs to be divided by what we have there as our x minus 2, right? And then you will agree with me that x minus 2 will divide out x minus 2, leaving us with just that x squared plus 2x plus 4. And then that is actually your y fully simplified. Now I'm going to begin doing my derivation. So I'm going to say dy over dx. My derivative dy over dx will then be the derivative of x squared is 2 times 1, which is going to be 2x to the power of 2 minus 1, which is 1. And the derivative of 2x is 1 times 2, which gives you a value of 2. X to the power 1 minus 1 is 0, so that's why we left just 2. And the derivative of a constant is always 0, so I'm not even going to write that. So this is a very nice example because it shows you that sometimes y is not the subject of the formula. You can't find dy over dx before making y the subject of the formula. So group all the y's, take it out as a common factor, divide, and if you still need to do simplification like this here, then do exactly that, so that everything is in the form coefficient, base, exponent, and then you are ready to start finding the derivative. The second example says find f double prime of x. So this question is not asking for the first derivative, but it is asking for the second derivative. They're asking us here for the second derivative, right? Please keep that in mind. Now, we first of all need to simplify before we can even find the first derivative. So what I'm going to do here is I'm going to divide every term by this x. I'm going to share this x and divide into all of those terms. So this means my f of x, I'm still sitting with f of x, is equal to 4x cubed divided by x plus 5x squared divided by x minus 7 divided by x. So that's actually what I'm doing. Divide everyone by what you have in the denominator. When you do that, you will notice that we now have x cubed divided by x. And according to the laws of exponents, when you're dividing same bases, you subtract the exponent. So on the first one here, I'm going to have 4x to the power of 3 minus 1. You're subtracting the exponent. It will give you a 2. On this one, I have 5x to the power of top exponent minus bottom exponent. 2 minus 1 is 1. That's why I'm going to have 5x. On this one here, it's not ready for differentiation, so I'm going to move it up. It's currently x to the power 1, and when you move it up, it's going to be 7x to the power of minus 1, because we need them to be in the form coefficient, base, exponent. Now, everyone is ready. My f of x can be simplified to what we are looking at now. So I'm going to first of all start by finding the first derivative. They said they want me to find the second derivative, so let's start with the first one. So the first derivative is this one. F prime of x is exponent times coefficient gives you 8, x to the power of exponent minus 1, which is 1. 1 times 5 gives me a plus 5, x to the power 1 minus 1, which is 0. So I'll just have 5 remaining. Negative times negative gives you positive 7, x to the power of 1 minus 1, which gives us minus 2. And that is the first derivative. But the examiner is not interested in the first derivative. They want me to find the second derivative. So which means what I have must be derived again. So then I'm going to say my second derivative with respect to x is 1 times 8, which gives you 8, x to the power of 1 minus 1 here, which is going to be 0. And anything to the power of 0 is 1, so we're going to ignore that. And then we're going to say the derivative of 5, which is a constant, is just 0 again. We're not going to write that. And then here, minus 2 times 7 is going to give you minus 14. X to the power of minus 2 minus 1 gives you minus 3. And then in conclusion, the second derivative with respect to x is 8 minus 14 divided by x to the power of 3. And that is how you find the second derivative of a function.